Good morning students, it's me Sudarshan sir. Today we are going to deal with computer science. What's the next topic? The binary system. Okay, we are going to see about the binary system. Take a book, take pencil. Mark important points which you feel it is necessary. Okay. Binary system. I hope in 6th standard you studied about the binary number system very clearly. But once we will see about that. Okay. Digital computers have chip containing million of tiny electronic switches. We know very well that if you studied well in 6th standard, it is sure that you know very well. Inside the computer you have something called memory chip. There only data are stored. Okay. How the memory chip will be? A memory chip will have millions of tiny, very small, tiny switches. Okay. In the switches, these tiny switches are also called as bit. Each and every tiny switches, actually it is technically in computer language it is called as bit, B-I-T, bit. This one. Okay. It's called bit. Okay. When the bit is on, there are millions of switches. In that, when one bit is on, it represents 1. When that bit is off, it represents 0. In millions of switch, if some switch is on, if some bit is on, it represents 1. When the switch is off, it represents 0. This is called binary system. 1 or 0. Zeros or ones are called as binary number system. Either 0 or 1 are called as binary number system. Okay. The data or instruction given to the digital computer must be in the form of 0 or 1. These codes are called binary codes or binary number system. See, whatever the data you feed into the computer, for example, you are feeding video into the computer, means in the sense you are storing video in the computer, you are storing your games in the computer. For you it is a game, for you it is a video, for you it is you may store song, for you it is a song. But does the computer know it is song, it is video, it is game? No, it doesn't know that, because it is a machine. It doesn't know all those things. How does it know? It knows only 0 and 1. Okay. The video you store in the computer will be converted into 0, 1. The song you store will be converted into 0, 1. The game you store will be converted into zeros and ones. Okay. All those zeros and ones, where it will be stored? It will be stored in the memory chip which is there inside the computer. Okay. Inside the computer, it will be in memory chip. It will be stored as zeros and ones. But for you, the computer will convert it into video, audio, game. Okay. But while you store, for the computer understanding, the processor will convert it into 0 and 1, and it will store in the memory chip. This is how it works. Okay. You will store as video. That video will be converted into 0 and 1 and will be stored in the memory chip. While you want to open the video and see, that 0 and 1 is converted into video and it will be shown in the screen. Okay. This is the simple process what carried out in the computer. Okay. In this system, a correct combination of zeros and 1 represent all numbers, letter, punctuation marks, special characters, everything. See, in this keyboard, you are typing Q. As a video song I told, same only here also, you are typing Q. Does the computer know it is Q? No, it doesn't know it is Q. So how the computer understand? As a machine language. How the computer will convert this Q into zeros and ones. Okay? Zeros and ones. Okay, that's it. Okay, how it will what combination of zeros and 1 represent this Q? That is what we are going to see. Okay, see, for number 1, we will see for numbers. For number 1, you are typing this 1 number. How the computer understand? By this combination of bits. All these bits are what? Millions of switches. In that millions of switches, 8 switches forms a group. In either switch or bit. Each and every 8 bit forms a group. That is called byte. This one. Byte. That is called byte. Each and every 8 bit forms a group. That group is called byte. Okay. So how many byte can be divided? Depends upon how many millions of switches are there. If there are many millions of switches, many bytes can be stored. Bytes will be there. If there are few millions of switches, only few bytes will be there. This is how you categorize your memory space. 1 GB memory I have, 10 GB memory I have, 512 GB memory I have. Okay, how it is how you will find it depends on the millions of switches in the memory chip. If your millions of switches or millions of bits are large, your byte will be large, so your storing capacity will be large. If it is less, your bit will be less and your byte will be less, so your storing capacity will be less. Okay, this is a simple concept. Okay. So when you press number 1, how the computer understand? You will press number 1 only, but the processor will convert it into this way: 0 0 0 0 0 0 0 1. So it is 8. Totally now 8 bits are there. So how the computer understand? With a combination of 8 bits. Okay, it will understand this 1 is pressed. For while 2 is pressed, how the computer will understand? For you it will show as 2, but how the computer will understand? It will convert into 0 0 0 0 0 0 1 0. It will convert into this form. Only then the computer will understand 2 is pressed. Like that only your video is stored, your song is stored. You will store as video, but it will convert into this form and it will store in the memory chip. Okay, this is how the computer works. Understood, students? Okay, now we are going to see about now you know how the computer will the processor will convert in this way, but how the processor will convert, in what method? In this method only the processor will converting decimal number to binary number. In this method only, there are few other methods also. I will let you know. I will teach you clearly. Okay. Okay, students. Now we are going to deal with converting a decimal number into binary number system. Okay, we will refer in note. Okay, converting decimal number to binary number. This process is done because the computer understands only binary numbers. So if we press decimal number, it will convert into binary number. Why this is done? Because the computer knows only binary number, so it should convert into binary number. Okay, any decimal number can be converted into binary number, that we know very well. How it will convert? By dividing by 2, by dividing the numbers by 2. Okay, repeatedly by 2, that is to be noted. By dividing any number repeatedly by 2. Example, take the number 5. Okay, if you take the number 5, first it will be divided by 2. So what will be the balance? 2. What will be the answer? 2. So will there be any balance? Yeah. 2 divides only 4 only, right? 2 divides 4 only. So 5 is there. So what will be the balance? 1. So this 2 is again divided by 2. So what will be the balance? What will be the answer? 1. So will there be any balance? No, 2 is actually divided by 2. So answer will be 1. No balance will be there. So balance is 0. So what is this concept? Take from down to top. 1 0 1. Okay, write down here. Leave these things. Write down here. 1 0 1. It means this 1 0 1 represents binary number. I mean decimal number 5. This binary number 1 0 1 represents decimal number 5. Only 3 number is there, but you told 8 numbers forms a byte. So what you should do? Add numbers with these 3 numbers. Add all other zeros with these 3 numbers. Okay. Why we are adding zeros? Because 1 and 1 means only these 2 switches are on. All other switches are off. No value. So all other switches are off. So the decimal number 5 represents the binary number 0 0 0 0 0 1 0 1. Okay. Is this correct, sir? Okay. We will find whether it is correct or not. How to find whether the computer did this process? That is okay. How to find whether the computer does the correct process? We will see about that. So for finding out only, we have something called place value. What is place value? In maths you could have learnt. Place value is nothing but ones, tens, hundreds. If you have more money, how will you find out? By using the place value only. If for example 5432, how will you find this is how many rupees? By using place value only. Last number's place value will be ones. Second last before number will be tens, and then it will be hundreds, and then it will be thousands. By seeing this you can easily understand. 5 means 5,000. 4 means 400. 3 means the 10, 20, 30. 30. 2 means that 1, 2, 3, 4. 2. So it will be like 5,432 rupees. You can easily find out. By what? These place values. These place values are multiplied by 10. 1 into 10. 10 into 10, 100, 100 into 10,000. Okay. So for finding decimal number, you have some place values. To represent some decimal numbers, you have some place values. Meanwhile, like in binary number system also, you have some place values. Okay. Okay, here it will be different. Here it will be multiple of 2's. There in decimal number it will be multiple of 10's. Here it will be multiple of 2's. Okay, okay. We'll see. That take the same 5 as example. Take the same decimal number 5. So what is the binary number? This is the binary number. Write this binary number here. What we are going to do? We are checking whether this answer is correct. Okay, this 5 answer is correct. For that we are representing it place values. Okay, here what it is divided, the place value 2's. 1, so first will be 1's, next 2's, 1 into 2 2's, next 4's, 8's, 16's. 4 means what? 2 into 2 4, 4 into 2 8, 8 into 2 16, 16 into 2 32. So here 2's. In decimal it is 10's. Here it is multiple of 2's. Okay. Okay. So 1's, 2's, 4, 8's, 16's, 32's, 64's, 128's. So 8 bits are there. Their place value is denoted here. Now we will check whether it is right. See, all other bits corresponding place values are of all these first 3, 4, 5 zeros. Because 5 zeros, so their place values are no use. These switches are switched off. These bits are off. These are bits only now. Either switches or bits. These bits are off. Here also 1 bit is off. So only 2 bits are on. Okay. So add this. So what we should do? Actually the same thing only. We should add these 2 bits alone. Add these 2 bits. 4 plus 1. So what you will get? 4 plus 1, 5. So the decimal number 5 represents this binary system, and this is correct. Both are same only. This is correct. So what the decimal number system is correct. So how to find? How will the computer will convert? By dividing everything by 2 only. Okay. Okay. Why I have explained about this place value for your reference to since you know to understand. I have explained about the place value, but how the computer will convert? Only using this division of 2 only. Okay. Okay, students. Okay. 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 That's it, students. Next we will see about. Now the computer converted decimal number into binary number. Now the computer understands. So it will again convert. So computer will do not again. It will do one more process, converting the binary number into decimal number. For making us to understand, we will see about that. Now next concept, students, converting binary number to decimal number. Okay. Because the computer will make us to understand by converting this process, because we know decimal numbers only now. If it shows in the computer 1 0 0 0 0 1 1 1 1 1, do we understand? No, we know 5 6 7 10 12 like that only, right? So it will convert to decimal number for our understanding, and it will show in the screen. Okay. Okay. Take the same 5 which we saw before. Take the same 5. So what is the binary number of 5? 101. Either it is you can write 101, else you can write the 8 digits also, 0 0 0 0 1 0 1. Okay. This for simple understanding I wrote. Okay. 101 means for converting decimal to binary we divided. Now in binary to decimal, what we are going to do is we are just going to multiple. Okay. Okay. We'll see the long one itself. We'll see this one itself. 5 means 8 digits. We'll see this one itself. What we are going to do? We are going to multiple. Okay, each and every number by into 2. We are going to multiple by 2. Okay, there we divided by 2. Here we are going to multiple by 2. There we repeatedly divided by 2. Here we are going to repeatedly multiple by 2. Okay. Okay. First number into 2 plus second number into 2 plus third number into 2 plus fourth into 2, fifth into 2, sixth into 2, seventh into 2, eighth into 2. Okay. That is what we have did here. Okay. 0 into 2 plus 0 into 2 plus 0 into 2 into 2 into 2 into 2. Okay, sir. We have did all those into 2, sir. Why we have represented powers to that, sir? Because that is the rule. 2, we have multiplied into 2, but we have to say how many times to multiple. That is why we are using the power symbol. How many times to multiple this? Okay. See. So how many numbers are there? 8 numbers are there. So how many times to multiple each and every number? That is what we are going to see. You for the power you write 0, 1. From the last number only you should write the power. You should start with 0. Okay, you should start with 0 only. So you write 0, 1, 2, 3, 4, 5, 6, 7. Why only 7? Because it starts with 0. What is the total number? 8. How many numbers are there? 8 numbers. So how many power you should give? 8 power you should give. But from what number will you start? You will not start with 1. You will start with 0. Okay? Okay. That is the basic rule of math. You know that very well, right? You could have studied in math, right? Okay. You will multiply, you will start with 0. Okay. So, any number to the into 0? 0 only. Into 0, 0, 0, 0, 0, 0. Till here it will be 0 only. Because any number into 0, multiple of 0, 0 only. So here, 1 into 2 to the power 2. 2 into 2 is 4. 4 into 1, 4. So what will be the answer? 4. Next, 0 into 2 to the power 1, again the same thing, 0. Any number into 0, 0. Here, 1 into 2 to the power 0. In math, you should know very well that any number to the power 0 is 1 only. Any number, even if it is 100, even if 1000 to the power 0 also, 1 only. Okay, okay. So 1 into 1 is equal to 1. So 0, 0, 0, 0, 0. I mean 0 plus 0 plus 0 plus 0 plus 0 plus 4 plus 0 plus 1 is equal to 5. So what is shown here? Binary is converted into decimal. This binary is converted into decimal. Okay, okay. The computer does this process to make us to understand. Okay, okay. Because it should show in the output screen as 5 only now. To do that process, the processor will do this process. It will convert binary into decimal. Okay, okay. Next, converting decimal number to hexadecimal number. Okay, see, till now we saw about binary to decimal. Okay, but one problem is there. What is this? The biggest drawback of using binary number system is that you have to deal with a long complex string of zeros and ones. We know that if it is a very long number, it will be very complex to understand that zeros and ones. Another number system that can solve this problem is known as hexadecimal number system. So one new number system is introduced, that is hexadecimal number system. Okay, as the name implies, this system has 16 unique symbols. See, the computer now understands hexadecimal number system. Why the computer is made to understand hexadecimal number system? Because zeros and ones, that binary number system takes a long process, so it may confuse and it will be irritated for sure if it is for a long numbers or long letters. So to overcome that, we have introduced something called hexadecimal number system for the computer to understand. So what this system does, as the name implies, this system has 16 unique symbols. Okay, according to the name implies, this system has 16 unique symbols. The digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. You count and see. So totally 16 will be there. 0 to F. 0 to 9 and A to F. So how many numbers will be? 16 numbers will be there. A represents value 10. B represents value 11, C represents 12, D represents 13, E represents 14 and F represents value 15. Okay. After 9 only, A will be 10, B will be 11, C will be 12. Okay. Next, we'll see how it does. Converting decimal to hexadecimal to make the process easy. Why this hexadecimal is found? By converting decimal to binary, the process is very high, very tough. If it is converted into hexadecimal, the process is very easy. Okay, we'll see about that. Converting decimal number to hexadecimal. Example, one number you take 459. You are taking 459. Hexadecimal means 16. Binary, I mean, in the binary you have divided it by 2. But hexadecimal in the sense you should divide it by 16. 459. For example, this number is taken divided by 16. So what will be the answer? How many times? 28 times. It will go 28 times. So what will be the balance? 11 balance will be there. You divide and see. You will easily understand. And this 28 should also should be divided, right? So it will also be divided by 16. So one time only it will go. What will be the balance? 12 balance will be there. Okay. See this. So from take down to up. 1, 12, 11. So write it down. 1, 12, 11. So 1 is written here. So what is this 12 means? 12 means C. See, you have seen before, right? 12 means C. In this you see. Represent how many hexadecimal numbers? Till F it is there. So 12 means what it represents? It represents C. C represents value 12. So 12 represents C. And one more number is there. What? 11. Before, above that 11 was there. 11 represents what? 11 represents B. B represents 11. So here 11 what will be represented? B. So what will be the answer? 1CB. So 449. What is the hexadecimal number system of 449? Hexadecimal number is 1CB. Okay. Why this is done? For easy conversion and for faster process, the computer does hexadecimal conversion. Okay, students. Next. Finally, one small concept. Converting a hexadecimal number to decimal number system. Why it is doing again the same process? Now only decimal to hexadecimal. Now why it is again converting the hexadecimal to decimal? Nothing, the same thing. To make us to understand. If instead of 459, if in display it shows 1CB, will you understand? No, we won't understand. So it will again, this is for computers understanding, this 1CB. Okay, for again human understanding, it will convert that 1CB into normal number. Why? Because we know only 459. Okay. So how it will convert? Converting hexadecimal number to decimal number. How it will convert? Here also one example we'll take. 7C. We'll take the example as 7C. Okay. So it will be like there you divided by 16. Here also the same thing only, no? Here you will multiply by 16. Okay, right? Okay, multiply by 16. Okay, first number 7. 7 into 16 plus second number C. C into 16. Only two numbers are there. Okay, 7C. So according to that only power will be given. So how many power will be given? Only 2 power. 0, 1. That's all. If it is 7CA, 3 number will be there, so 3 power you will be giving. 0, 1, 2 you will be giving. Now here only 2 numbers are there, so only 2. It will start with 0 only. Always the power will start with 0 only. 0 and 1 you have given. In max and all you could have studied this well and good, right? Okay, we'll go through that. Next, 7 into 16. So what does this mean? 16 to the power 1 means only 1 time 16. So 7 into 16. Any number to the power 0, before as I told, it will be 1. So 12 into 1. Why it is 12? Because C means 12. So 12 into 1. Because we are converting hexadecimal to normal decimal number. Okay. 7 into 16 is 112. 12 into 1 is 12. So what will be the total? 124. So 7C means for us it will show 124. Okay. If you write 124, if you type 124, the computer will convert it into 7C. But for showing you what it will do, it will convert these 7Cs into 124. Because we know that 124 only, right? If we saw 7C, do we understand? No, we won't understand. That's it, Kana. That's it, the topic of conversion of all these processes. What are the processes we converted today? Binary to decimal, decimal to binary, decimal to hexadecimal, hexadecimal to decimal. All these things we saw. Okay. If you have any doubt in this, just go through this video again and again. Stop where you didn't understand and you go through this. Beyond this, if you have doubt, just text me. And also, if you are free, you can refer net. Okay, no issues. Okay. Next, see there itself they have given. We shall not go into other mathematical operation in this book because it will confuse. Okay. You have learnt about storage unit in previous classes. In 6th standard and all, you could have learnt about storage units. The storage capacity of a computer in bytes is also measured in powers of 2. In the storage capacity of computer is referred as what? Byte. 1 gigabyte, 1 kilobyte, 1 megabyte, 1 terabyte. It is represented in byte only. Okay. See. You know it is represented in byte. You know 1 KB, you know 1 MB, you know 1 GB, you know 1 TB, you know all these things. Okay. Since everyone have computer, we know about memory space very well. Okay. But how this memory space is actually allocated? It is actually allocated with 2 to the power 10. With this 2 to the power 10. So 1 KB means what? 1 kilobyte. 1 KB means 1 kilobyte. Okay, 1 kilobyte, how it is allocated? 1 into 2 to the power 10. 1 into 2 to the power 10. So what will be the answer? 1024 bytes. Next, 1 megabyte, 1 MB is 1 into 2 to the power 10 KB. So what will be the answer? 1024 KB. 1 gigabyte. 1 gigabyte is equal to 1024 MB. That we see, this one we know very well. 1 KB is equal to 1024 byte. 1 MB is equal to 1024 KB. 1 GB is equal to 1024 MB. 1 TB is equal to 1024 GB. All these things we know very well. How they have calculated this 1024? By every number into 2 to the power 10. Every number into 2 to the binary means into 2 only now. So 2 to the power 10. 2 to the power 10. 2 to the power 10. 10 times they have divided. If you divide 2 into 10 times, what you will get? 1024 only you will get. So by this only storage space is allocated. See, 10 times I have multiplied. Not divide, sorry, multiple. 10 times I have multiplied. So what you will get? 1024. This is how the memory space is allocated. So this is how 1 KB is equal to called 1024 bytes. This is how 1 MB is equal to 1024 GB. See, KB. This is how 1 GB is equal to 1024 MB. This is how 1 TB is equal to 1024 GB. If you put 1 GB internet, how many MBs will be credited in your balance? 1024 MB. If you put 2 GB internet, what will be the balance? 2048 MB. Okay, this is how a GB or MB or this memory space is calculated. Okay. PCs today normally have primary memory of 4 GB and 8 GB, secondary memory of 500 GB, 3 TB and so on. Nowadays you have very good memory space. You have 512 GB memory, so you can store more videos, more movies, more songs. All this it can be done in the present world computer. Okay, but that memory allocation is done how? With the help of this process only. Okay students, I hope you understood. It may be little bit complicated, but no issues. Go through the video once again. If you have beyond that, if you have doubt, call me or text me, and you can refer internet also. No issues. Take care students, take care, bye.